going to take a look at one of these, I call these rate problems, because this is all about rates. When I look at the rate, what am I talking about? Elizabeth, what am I talking about with a rate? Yes, it's the amount divided by the what? Time, yeah. So if I'm looking at the rate in which I pay interest, it's money per year. If it's the rate in which I eat hot dogs, it's hot dogs per minute. If I'm looking at gardening, what am I talking about? Taylor can weed the garden in 4 hours. Well, what we're talking about is the weeds per what? For what in this problem? Hours, yeah. Does that help? That's a good start. And then for formulas, the rate in which Taylor can weed a garden plus the rate in which, what's his name, Carl? Carl can weed the garden is going to be equal to the rate in which who can do it? Both of them, yeah. So write that formula down. This is the key to making this work. So you're good with algebra. You'll be fine with that. It's just this idea that rate plus rate equals rate is what confuses people. So now when we look at Taylor, how long did it take her to do the one job? 4 hours. Yep. How long did it take Carl to do the one job? Don't know. How long did it take both of them to do the one job? 3. So the formula that you have here is just 1 out of 4 plus 1 out of x is equal to 1 out of 3. Now let's look at the numbers and make sense a little bit. Does it make sense that it took less time for both of them to do it? Yeah, so that's good. If it took more time, this isn't going to work out. You're not going to have an x that works. So once you get to this part, now you're going to say, are we okay with the one job in time? Is that all right? It's weird because it doesn't say one job, but you're weeding the whole garden, weeding the whole garden, weeding the whole garden. So it's one job. So then for simplifying this number of different ways, have you ever heard of clearing fractions? Alec, have we done that? Have we done the clearing fractions? Does that sound familiar? Yeah, so what you could do is the denominator is 4 times x times 3, or just go 4 times 3 times x, 4 times 3 times x, 4 times 3 times x. And what's neat about this is that you can see the 4's canceling, the x is canceling, and the 3's canceling. So that's going to be 3x plus 12 equals 4x. So if you subtract 3x, you get 12 equal to 4x minus 3x is x. So it's actually going to take Carl 12 hours. Carl. Headphones out, Andrew. Thank you. Yep. So yeah, it'll take him 12 hours. You don't have to do it this way. You could do it a different way. At this point, what could we do? Will this let me do it? Yes, yay. What could you do if you're solving x? What's another way you could have done it? Did anybody see it? Instead of clearing the fraction. Nathan, any idea? Solving? We were solving for this, right? So just what could we do? Yeah, love it. 1/3 minus 1/4 if you want to do that. And now all you have to do is do 4, 4, 3, 3. 4 minus 3 is 1. 4 times 3 is 12. So if 1 over x equals 1 over 12, you can say that x is 12. Do you like that method better? Either way, doesn't matter to me. Let's see, a box with a square base. This one looks kind of familiar to me. A box with a square base has no top to be constructed so that its volume has 1,000 cubic centimeters. Let x denote the width of the box and seen below. All right. So box with a square base. So if this length is x, what will this one be? X. Yep. And let's call the height h. Oh, I like this one. This is good. So the volume is going to be equal to x times h. Did they tell us what the volume is? Did they say the volume is blah? Yeah, it's 1,000 cubic centimeters. So we're going to call this 1,000. This x squared times h. Solve for h. Okay, so express the height as a function of the width. So h is just going to be equal to 1,000 over what? X squared. You got it. Good. Now, then it says for this part, solve h of x greater than or equal to x. So this 1,000 over x squared has to be greater than or equal to x. So then what we could say is 1,000 greater than or equal to x squared times x. And what's the cubed root of 1,000? I bet you could tell me what that is. Cubed root of 1,000? What times what times what is 1,000? 10, yeah. So x is just going to be less than or equal to 10. All right. Okay, let's go to part 3. Find and interpret the behavior as x goes to 0. So what is going to happen to the height if the width is really, 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 really small? What's going to happen to the height? Yeah, it's going to get taller and taller. So we would say for this part, as x goes to 0 on the plus side, the height goes to infinity. What if x goes to infinity? What's the height going to do? Shrink. And then the height goes to 0. Well, that's cool. Express the surface area. I'll let you figure those out. Those two are fine. All right. Go to, boom, 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 21 and 22. Go to 24 and 25. Do those two first. I'll feel so good if you can get those done. And then we just have one other word problem I want you to do.